We humans are apes, and for most of our 300,000 year history, we've lived very similar to how our ape relatives lived. But then, around 12,000 years ago, the last ice age ended, and by that time, we learned how to farm. But farming didn't take over the world immediately. It wasn't until around 5,000 years ago, in the so-called Fertile Crescent in modern-day Turkey, Syria and Iraq, that farming gave rise to something that would reshape our entire planet. In that region, communities began to cultivate these three types of wheat. And cereal crops like these are very special because they have a number of properties that allows for a ruler to use them for taxation. And that, in turn, allowed for the creation of a state. With wheat as a bureaucratic backbone, the world's first states and empires took hold in the Fertile Crescent. And not long thereafter, people took their wheat and they expanded in three main paths. Along the northern shore of the Mediterranean to the Iberian Peninsula, along North Africa down the Nile and to Ethiopia, and also north along the Danube River towards northern Europe. As these crop-growing civilizations carried their crop seeds to different places, the crops adapted to local climates and soils, and over the millennia, an eclectic set of crops developed. In Egypt, variants of emmer wheat flourished and fed the people who built the pyramids and were placed in the tombs of the pharaohs. In the eastern Mediterranean, emmer spun off into durum wheat, and in Central and Northern Europe, the subspecies spelt wheat thrived. These adaptations of wheat came about through what we can call mass selection. Every time farmers planted wheat seeds, the plants that grew had naturally occurring variation, and what farmers did was to simply keep seeds from the plants that best suited their needs in that place.
You might say, well, we're going to replant the seeds from this because it's a short type and we want to encourage a short type, and we're going to replant the seeds from this one because it's the one that didn't get the disease that the other ones got. And so passing on genetic diversity from generation to generation.
This is Glenn Stone, environmental anthropologist, senior research professor at Washington and Lee University and Guggenheim Fellow. Stone began his career as an archaeologist studying ancient farming. He then spent decades doing field research with small-scale farmers in Nigeria, India and the Philippines, after which he transitioned to biotechnology, studying gene editing and digital agriculture. In his latest book, The Agricultural Dilemma, Stone methodically dismantles the myths that have been built around modern agriculture.
So in mass selection, you are keeping genetic diversity in your field.
So to summarize, since its inception, our agricultural food system is built on farmers using so-called mass selection. But in the 20th century, a new paradigm of breeding would take over, and it all started with an Austrian monk called Gregor Mendel.
Gregor Mendel was an Austrian monk, but he also had some scientific training. And in the 1850s and 1860s, he was doing a bunch of rather ingeniously designed experiments with pea plants.
So in his experiments, Mendel took pea plants with different visible traits, and then he intentionally crossed them. He, for example, crossed plants with yellow peas with plants with green peas, tall plants with short plants, etc. He then carefully recorded what traits appeared in the offspring of these crosses and then what appeared in the generation after that. And then after 7 years of meticulous cataloging over 28,000 plants, Mendel deduced some profound patterns.
He managed to work out on his own a lot of the basic rudimentary ideas of the modern field of genetics. And he published this, and it had very little impact on the world of science.
Not until 3 decades after Mendel published his findings did people recognize its significance. But when they did, it would lay the foundation for a new paradigm in plant breeding.
Breeders became intrigued by what they called Mendelian breeding. And this means moving away from mass selection, which keeps diversity in the field, towards sorts of breeding that produce more homogeneous lines so that you can isolate specific traits and see how you can manipulate those traits, as opposed to mass selection where you are maintaining a population that's diverse and you're improving many traits all at the same time.
In the 20th century, Mendelian breeding would end up replacing mass selection almost completely. Nearly all the food we consume today, everything from tomatoes, potatoes to bread and beer and animals raised on crops, comes from plants bred through Mendelian methods. This shift has had 4 profound consequences, and I will explain what those are. But first, we need to talk about the conventional narrative around modern agriculture, because during the same period as the transition from mass selection to Mendelian breeding, the world's population grew from 1.6 billion to over 8 billion people. And what the conventional narrative says is that this growth wouldn't have been possible without Mendelian breeding. Basically, that Mendelian breeding saved the world from mass starvation. And as evidence of that, people usually point to 2 examples: hybrid corn and Norman Borlaug's Green Revolution. We humans have known for a very long time that inbreeding is a bad idea. Inbreeding within English bulldogs has produced animals who struggle to breathe and whose skulls are too large to be born naturally. Inbreeding within the Habsburg dynasty resulted in Charles II, who couldn't chew properly and was infertile and could barely speak and died only 38 years old. Inbreeding to produce white-coated tigers for circuses has resulted in animals with crossed eyes and very short lives. Similarly, if you deliberately inbreed a corn plant by taking pollen from the tassel and applying it to the plant's own silks, you get offspring that are weak and unproductive. Therefore, it may seem bizarre that a number of American geneticists in the early 1900s conducted Mendelian experiments where they did exactly this. They deliberately inbred lines of corn over many generations, creating so-called pure lines. Then they crossed these different pure lines with each other, and what they discovered was remarkable.
And every now and then, not very commonly, but every now and then, you can cross 2 pure lines which don't really grow very well on their own and get an offspring that's very productive. And so they called this hybrid vigor. To make it more scientific, they invented a term for heterosis.
So these new hybrids that geneticists developed, they were allegedly more productive because of heterosis. But, and this is important, so listen carefully, if you grow hybrid plants and if you try to replant the seeds from those hybrid plants, then the offspring will not be as strong as the first generation. The offspring will not have heterosis. This means that hybrid farmers can't just produce their own seeds like farmers have always done. Instead, hybrid farmers need to buy new seeds from a seed company every year. And therefore, seed companies realize that they can make a lot of money selling hybrid seeds.
The corn seeds they'd sold before, the farmers would buy them. Then they had this deplorable habit of replanting their own seeds, which was a real obstacle to the growth of the seed industry, and that habit had to be stopped. And hybrids were a way of getting them to stop that.
The only challenge for the seed companies was to get farmers to adopt these new hybrid seeds. But to achieve that, they had the best ally imaginable. This is Henry A. Wallace, an Iowa farmer who in the 1920s founded Pioneer Hybrid Company, one of the first commercial hybrid seed companies. In the 1932 US election campaign, Henry was an active supporter of Franklin Delano Roosevelt and helped swing Iowa from Republican to Democrat. For this, FDR appointed him Secretary of Agriculture in 1933.
And he used the power and the propaganda abilities in the president's cabinet to promote hybrid corn relentlessly.
From when Wallace's propaganda campaign started in 1933 to 1945, the share of corn from hybrids in the US went from 0.4% to over 90%. This adoption obviously provided a massive windfall for the seed companies like Funk, DeKalb, and Henry Wallace's own company, Pioneer. Therefore, it has been in the seed industry's interest to claim that this adoption had nothing to do with Henry Wallace's propaganda campaign or because the US government has given massive direct and indirect subsidies for the adoption of hybrid corn. Instead, the industry has needed to adamantly claim that farmers adopted hybrid corn because it provides better yields. But does the data really support that?
There's a famous chart, corn yields in the US over time. For many, many decades, it's sort of a flat line, and then they adopt hybrids, and the line just goes up and up and up. And so people show this graph, and it seems to be self-evident that hybrids led to this huge surge in yields, and that's a good thing. But if you make a similar chart of yields of other commodity crops in the US that were not hybrids, they go up in the same way. Yields were rising in the US because during those years there was increased mechanization and there was increased fertilizer and a series of other things were going on. So it wasn't because of hybrids at all. It's just part of this heroic story that people make up.
This heroic story about hybrid corn is sometimes called the American Green Revolution. But there is a second, more famous myth about Mendelian breeding, and it goes by the name of the Green Revolution. So the legend goes something like this. After World War II, India had a massive population boom, but its agriculture was struggling to keep up. Then in 1965 and 1966, severe droughts hit, harvest collapsed, and with a population of over 1 billion people, India faced the prospect of famine.
And then Norman Borlaug, the hero of the story, the square-jawed son of the soil from Iowa who had been breeding wheat, he persuades India to adopt his miracle semi-dwarf wheats. They are a modern improved variety, and they're highly productive, especially if you fertilize them. And then the first year they adopt them, 1968, they have a bumper harvest. Norman Borlaug wins the Nobel Peace Prize, and he saves 1 billion lives. That's the legend.
This legend of Borlaug using Mendelian breeding methods to save 1 billion lives in Asia is also referred to as the Green Revolution. And it's been told and retold for decades. Bill Gates, for example, he has called Borlaug's Green Revolution one of the greatest achievements of the 20th century. There's just one problem with this legend.
Everything about it turns out to be wrong. Or, if I might say, everything about it turns out to be complete bullshit. They started planting all this new Green Revolution wheat in 1967, but then in 1968, when they say that the Green Revolution produced all this extra food, the rains came back and all the crops became more productive. If you actually look at the trajectory of food grain production in India, not just wheat, but food grain production, which really is the whole point. And if you make a chart of how fast food grain production was growing before that 2-year drought, and you continue that line, the line doesn't change. In other words, the Green Revolution didn't produce any food that wouldn't have been produced anyway. And so I've gone to great trouble to calculate the number of lives that were actually saved. It wasn't 1 billion, it was exactly 0. There were absolutely no lives that were saved.
So for thousands of years, farmers improved their crops through mass selection. Then in just 100 years, Mendelian breeding methods took over almost entirely. Was this rapid transition necessary to prevent mass starvation? Well, neither hybrid corn nor the Green Revolution holds up as evidence of that. In fact, as the 1998 Nobel laureate in economics, Amartya Sen, has shown, famine has almost never anything to do with a lack of food.
There has never been a famine in a democratic country, even very poor one. If a famine were to develop, democracy provides a guarantee for stopping it, because famines are extremely easy to stop.
The argument that we need Mendelian breeding to prevent famine simply doesn't hold up. Instead, what that argument does is that it distracts us from the 4 real consequences of the transition to Mendelian breeding. And the first consequence is that Mendelian breeding has made farmers dependent on a corporate input system. So in the last 80 years, chemical companies and seed companies merged en masse. Why? Because they realized that they can use Mendelian breeding to develop seeds that only perform well if farmers also buy their fertilizers, pesticides and herbicides. Today, just 4 companies control both 51% of global sales of seeds and 62% of global sales of agrochemicals. These corporations are the real winners of Mendelian breeding, but not everyone has accepted this system. This is Knutas. an organic farmer in Sweden who has transitioned away from industrial farming. He described to me what the industrial agricultural system feels like from the inside.
For me, it's a trap. When you have to buy a certain chemistry from a certain company and you have to use that fertilizer or that seed and so on. If you ask any farmer if they could choose, they would do it without chemicals, but they are so trapped in this system.
He also told me something that shocked me, which is that farmers who grow modern seeds from the big companies aren't even allowed to touch them with their bare hands, because the seeds are so heavily coated in poisonous chemicals. The second consequence of Mendelian breeding is quality. So the industry usually claim that they use Mendelian breeding to improve quality, but what we've seen is actually the opposite. Tomatoes are bred to be hard and uniform so that they survive mechanical picking and transport, instead of being bred for flavor and nutrition. Strawberries are bred to last weeks in a refrigerator but don't taste like strawberries anymore. Wheat is bred to give higher yields at the cost of lower protein and nutrients. The industry has used Mendelian breeding to optimize our food for everything except for what food is actually for. This is Sébastien Boudet, a French-Swedish baker and activist who is part of a growing movement pushing back against industrial Mendelian breeding by returning to ancient grains.
We've been fighting for years to keep the right to use emmer and einkorn and spelt and all those ancient grains that are absolutely amazing, that are so amazing to bake with and that are delicious. Without ancient grain, I don't think I would still be a baker today. I would have given up.
The third consequence is opportunity cost, because when the world committed to Mendelian breeding, essentially all efforts to improve mass selection stopped. But some researchers have argued that if the same investments had gone into mass selection, then those methods would be as good or better than Mendelian breeding today. Instead, today, it's almost exclusively small-scale organic farmers like Peter who engage in mass selection. The fourth and most important consequence of Mendelian breeding is the loss of biodiversity. In just 100 years, the world has lost 75% of the genetic crop diversity that it took millennia of mass selection to build. The governments are now desperate to save the remaining diversity in seed banks like the famous seed vault on Svalbard, but a frozen seed is not the same as a living variety. For seeds to remain relevant, farmers like Peter need to grow them every year in actual fields. There's one thing that really frustrates me after having done a lot of research for this video essay, and that is that despite everything that I've told you so far, Mendelian breeding in itself doesn't need to be problematic. It doesn't need to be destructive. The only reason that Mendelian breeding is destructive is that we've deployed it within an economic system that demands economic growth at all times. An economic system that obviously has lost all connection to what we humans actually need.
Well, the statistics are clear that the world produces and has for a long time produced far more agricultural product than is needed to feed the world. We really need to figure out how to produce less. There is so much impetus in all these input industries, and there's so much money attached to producing more and more, that if you say, let's develop some crops that are less productive and are more environmentally friendly, there'll be just extraordinarily well-funded attacks on you. So it's not an easy thing to do, just to produce less and less. It's really something we have to figure out how to do. How can we figure out how to produce less?
My name is Andres Acevedo and this is The Market Exit. So I feel about video creation a bit like Professor Stone feels about agriculture. What the world needs more of is not more quantity, it's more quality. We need less, but better. That's why I spend an enormous amount of time making just a few of these video essays every year, even though it would be way more profitable for me to just churn out simpler videos all the time. But the problem is that I cannot keep working this way unless I get supported by people like you. So if you find value in my video essays, I invite you to become a Patreon supporter at patreon.com/themarketexit. Any amount helps, and to my existing patrons, thank you very, very much. Also, as a final note, if you want to do something concrete after watching this video, I would urge you to start buying organic. bioorganic food is not just a way to resist the agrochemical industry, it's also a way to help small-scale farmers like Peter who are fighting to keep diversity in our fields. Alright, thank you for watching this video all the way to the end. Thank you, bye-bye.